Hi, questions in probability in this textbook. Problems in chapter 3. Problem 3.69. A certain organism possesses a pair of each of 5 different genes, A, B, C, D, E. Each gene appears in 2 forms, which we designate by lowercase and capital letters. The capital letter will be assumed to be the dominant gene, in the sense that if an organism possesses the gene K, small x, big X, then it will automatically have the appearance of the big X gene. The characteristic appearance of an organism is called its phenotype, whereas its genetic contribution is called its genotype. In a mating between 2 organisms, each one contributes at random one of its gene pairs of each type. The 5 contributions of an organism are assumed to be independent and are also independent of the contributions of the organism's mate. In a mating between organisms having genotypes, small a, big A, small b, big B, small c, big C, small d, big D, small e, big E, and small a, small b, big B, small c, big D, small d, small e. What is the probability that the progeny will 1. Phenotypically and 2. Genotypically resemble A. the first parent, B. the second parent, C. either parent, D. neither parent? Solution. Question 1. Phenotypically resemble. Note that for phenotypically resemble to the first parent, it should have those 5 letters. For phenotypically resemble to the second parent, it should have those 5 letters. A. Phenotypically resemble to the first parent. This case is illustrated by this figure. So the probability for this case equals 9/128. Case B, phenotypically resemble to the second parent. This case is illustrated by this figure. The probability for this case equals 9/128. Case C, phenotypically resemble to either parent. Here, we see that phenotypically resemble to the first parent and phenotypically resemble to the second parent are mutually exclusive. So the probability for the phenotypically resemble to either parent equals 9/64. Case D, phenotypically resemble to neither parent. The probability for this case equals 55/64. Question 2. Genotypically resemble. For genotypically resemble to the first parent, we have those letters. To the second parent, we have those letters. Case A, genotypically resemble to the first parent. This case is illustrated by this figure. The probability for this case equals 1/32. Case B, genotypically resemble to the second parent. This case is illustrated by this figure. The probability for this case is equal to 1/32. Case C, genotypically resemble to either parent. Here we see that genotypically resemble to the first parent and genotypically resemble to the second parent are mutually exclusive. So the probability for this case equals 1/16. Case D, genotypically resemble to neither parent. The probability for this case equals 15/16. Problem 3.70. There is a 50-50 chance that the queen carries the gene for hemophilia. If she is a carrier, then each prince has a 50-50 chance of having hemophilia. If the queen has had 3 princesses without the disease, what is the probability that the queen is a carrier? If there is a 4th prince, what is the probability that he will have hemophilia? Solution. Define the events E and Fi. We see this result. Then we see this result. Thanks for watching. Bye.